Okay guys, today I'm going to show you how to calculate sugar ring torsion and its correlation to pseudo-rotation. So this concept initially introduced by Altona and Sundaralingam in 1972, and I found a new paper here which is published in 2014, which has like a free energy landscape of pseudo-rotation. This will help to visualize everything, right? So let's first see how everything, uh, s- um, how we can see everything in the pseudo rotation. So I have like a VMD trajectory. It is basically a combined PDB molecule, 36 molecules. So this trajectory from 0 to 360, which is pseudo rotation from 0 to 360 and 10-degree interval. So basically I have like 36 PDBs here. One mean P is equal to 10 degrees, like 7 means 70 degrees, P is 70 at 70 degree, and 21 mean P at 210 degrees, right? And like 270 degrees, etc. So let's see how this works. So let's go to history first, and let's go to this paper. So this concept of pseudo-rotation was introduced in this paper, Altona and Sundarlingam. So this paper look like this, and they introduced concept that pentose sugar behavior, that sugar Parker behavior, bend of the sugar Parker is can be represented by five torsions. Uh, Five torsion mean I will show you. So five torsion mean if you have a sugar packer like this, so you can define this sugar packer with five torsion. So mu1 here, it will be this torsion from C4 prime, O4 prime, and C1 prime to C2 prime. And the next torsion will be O4 prime, C1 prime, C2 prime, C3 prime. It will be mu1. and and the other torsion is C1 prime, C2 prime, C3 prime, and C4 prime. It will be mu2, and the next one is C2 prime, C3 prime, C4 prime, O4 prime, mu3, and the last one is C3 prime, C4 prime, O4 prime, C1 prime, right? So based on these five torsion of pentose ring, you can define a pseudo rotation P. So the correlation between these five torsion is the equation is something like this. The pseudo rotation of tan is equal to mu1 mu4 plus blah blah blah, like this. And there's a simple version. You can write that equation like this. The theta j is mu1 or mu2 or mu3. So for j is equal to 0, and it will go to 0 to 4. And this theta m is the amplitude of the sugar. I will explain what is this amplitude, right? So we can simply write this equation like a modified equation like this. This is mu 0 to 4, and this is amplitude, right? So amplitude always are used as 42, which is the maximum amplitude for the RNAs. And this is the pseudo rotation, and this should be minus 0 or something like 1 second minus 2 here. Yeah, that's the equation. And so when if you want to calculate pseudo rotation is at 30 for mu 0. What is the mu 0? So it will be basically plugging this 42 here, cos this, and mu 0 is like a j is 0 minus 2. So I have calculated everything here for mu 0, mu 1, mu 2, mu 3, and mu 4. Plugging 1, 2, 3, 4, and 0. For all the p is equal to when 0 to 360, 0 to 360, right? Here. So for p is 0 to 360, we can get different uh, mu 0, mu 1, mu 2, mu 3, and mu 4 values, right? Okay, I'm going to undo this. And this second paper explain about something like this pseudo rotation and its behavior. Like when p is equal to 0, it is at C3 endo. So this is also visualized here. It's the same thing, but they say like this is below the plane, this torsion is below the plane, this is on plane, and this is above the plane, something like that. And around here it is C3 endo, and if you see this one around like a P around, what is it, 36, around 50, it will be C4XO. It's the same definition in like in a beautiful way. So I so this is a P 0 to 360, and we are going to see how this change in 3 dimension. Let's go. Okay, now let's see. So as I explained before, so this is 0 to 360, right? And let's see what's happening. What is this 0? 0 to here it is 36. Roughly this area is this is like 20, 20ish, right? So let's see what is at 20 degree. Let me show you something. It says C3 endo, right? Yeah, C3 endo. Say C3 endo. Okay. So let's visualize this atom. This is O prime and C1 prime, C2 prime, C3 prime, and C4 prime. So C3 endo. We are at 20. What is this C3 endo mean? It is endo mean it is like when we have this plane like this, so you can see these 4 atoms is in one plane, and this is the C3 is above the plane. So that's what is called C3 prime endo. On and it moved to like around like a 50 degrees here, and we have like C4XO. XO mean below the plane. So let's move this into like a 50, and now no more this is in same plane, but we can find C4XO. You see, this C4 is below the plane, right? And what is the next confirmation? C4XO exo, and this is O4 endo. So it is around like 90 degrees. So we move to 90 degrees, and this will be O4 exo. Right? You see these four atoms are in same plane, but O4 prime is above the plane. Right? That is O4 exo. Sorry, O4 endo. And now we are moving to C1 exo. So what should happen? C1 should be below the plane. Let's go 108. Roughly this is like 120. So it will be the 20th frame. Okay. So now you can see C4 is below the plane. So we cannot arrange any other atoms in the same plane. If you move around, like, you cannot actually. You cannot get any other four atoms on the same plane, and um, any other atom below the plane. So only just C1 prime is below the plane. So moving to the next confirmation, it is roughly around 150. So we go to 15 prime. It will be C2 endo. So what is it like? C2 section is endo now. Okay, it is not the perfect plane. Maybe it is, yeah, 16. Okay, so this is 10 degree interval PDB. I made this PDB using Gaussian, and I optimize. I will tell how I did it later. So next confirmation is C3 EXO. We are moving to the frame 190 maybe. Let's go to 190 and see if the C3 is EXO. Yes, we can see the C3 is uh, EXO below the plane. Alright, what is the next one? C4. C4 is 120. 120 C4 endo. This is C4 endo. Okay, this is C4 endo, right? And we are moving to the next confirmation. 270 roughly. It will be CO4 EXO, right? You can clearly see this O4 is below the plane. And the next one is C4 endo 190 to 290 around. It will be C1 endo 90. Yeah, it's roughly it is 300. Okay. Yeah, and this one is C2 prime EXO. So like 140 C2 prime EXO. Yes, this C2 prime is EXO now, below the plane. All right. So another interesting thing is you can see this C4 EXO is and the opposite is C4 endo. So let's try to jump into like 30, like 50 degrees to 20. So let's go to 50. 50, it will be C4 EXO. C4 EXO, and if you jump to 220, will be C4 endo. Yeah, that's how it works. 5 to 22. See? All right, that's how it works. So what's the next slide I want to explain? That's all about the P and mu relationship. So let's look into this, the P and mu0, mu1, mu2, mu3 in the actual values. I'm going to move this one here a bit. Oops. Okay, and let's see what we have. So now I'm going to visualize all the torsions. So this one, this one, this one, and this one. So mu1 is 16.8. Next visualize this one. Mu2 is 10 degree. Okay. Okay, this is mu4 is visualized now. This is minus 30. All right. What? All right. Now we have everything. Let's see how this is deviate. The correlation of everything. Okay. So at P is at 0. Let's get to P is at 20. Right? P is at 20. Amplitude is 42. What is this amplitude? Amplitude is the maximum angle that torsion can be bent from the plane. So from plane to upward, this angle is 42, right? It can bend like from 34 degree to 42 degrees. I use like 42 as the constant, the maximum value. And yeah, it also can bend to the downwards, the exo position, 42 degrees. So that's actually what it means. So this angle to the plane is 42 degrees. All right, let's go to this and see the relationship. So now we are at P is equal to 2n. So what are the values? Amplitude is 42, that's correct, right? Now at P is at 20, it is C3 prime n though, okay? And mu1 value is minus 47. So how I create this PDB is I restrain this mu1 and mu3 in different value, um, like if it is p is at 0, we p is at 20, I restrain this torsion at like minus 23 in Gaussian, and this mu3 at 40 degrees, and I optimize it. So I did like for like 36 molecule, and I combined those molecules together, and I get this trajectory. So I will upload and to somewhere and paste the link in the description. So let's look at this again. So mu1 is minus 1. So when you optimize in Gaussian and it slightly change, and mu1 is minus 23.6, mu2 is 39.7 something, and mu3 you can see 40.37 negative value, and 25.86. All right, so yeah, we can randomly check, like for example 170. 170, it is like 90 degrees for mu1, and mu0, mu1 is 37, and minus 41, it's slightly change, and this one is 29.1 here, and this one is minus 85. So that's the story about sugar torsions and all the relationship. So I hope this video clear you everything about regarding sugar ring torsion and the pseudo torsion relationship. Okay, see you in next video. Thank you very much for watching. Bye bye.